Today's focus is going to be on limiting and excess reactants. First, let's think about it in terms of sandwiches. We have bread and cheese. 2 slices of bread to 1 slice of cheese would make 1 sandwich. So if we happen to have 10 slices of bread and 3 slices of cheese, how many sandwiches can we make? Well, we could only make 3 sandwiches, and that's because we're going to run out of cheese before we use up all of our bread. So the cheese is known as our limiting reactant, which means that I'm going to have 0 cheese left over once I make my sandwiches. But 10 slices of bread, we're only going to use 6 of them to make these 3 sandwiches, so the bread is known as my excess reactant, which means that I'm going to have some leftovers. Once I use 6 of my 10 pieces of bread, I'm going to have 4 of them remaining once I make my sandwiches. Now, this 3 sandwiches is known as the theoretical yield, which means if everything goes perfectly as planned on paper, I should theoretically be able to make 3 sandwiches. Now let's say that we made these sandwiches on the countertop in our kitchen, and then our cute giant pit bull jumped up on the counter, nibbled on the corner of one of my sandwiches. I caught him just in time, smacked his nose and said, "Go away," but damage was done. He bit the corner of one of my sandwiches. So I'm going to just cut that half of the sandwich off, throw it away, and I'll keep the other half and I'll eat it myself. So this would be considered the actual yield of sandwiches, where not everything went quite as to plan, and so I didn't get the full amount of yield that I was expecting that I could. So if we do a comparison of the actual yield and the theoretical yield, we can actually get what's called the percent yield, which is where the actual is divided by the theoretical times 100. So my actual is 2.5 sandwiches. Divided by my theoretical 3 sandwiches times 100 means that I yielded 83% of my possible total yield. And so that would be considered the percent yield. Now let's consider this same example with a real-life chemical reaction. We have copper metal and silver nitrate solution, and when they react, they'll single replace to form silver metal and copper nitrate solution. So here's the example that we did in class, where we have a piece of copper metal and it was in a silver nitrate solution. This reaction has gone to completion, and you'll notice that we have our silver here, and then the blue solution is the copper nitrate solution that remains afterwards. So because we have copper left over after the reaction, we must have an excess of copper. So this will be considered our excess reactant because we have leftovers of the copper after the reaction went to completion, and the silver nitrate was my limiting reactant, which means I used up all of it, which means I have 0 of it left over after the reaction is completed. So now that we know which one is our limiting reactant and which one is our excess reactant, we can now calculate, if we want, the amounts of products that we're going to make given this information to start. So if I wanted to know how much silver I made in that reaction, then I can perform a stoichiometry calculation in the form of a proportion that looks like this. And so I would set up my proportion, and then once I solve for x in this proportion, I will have calculated the theoretical yield of silver that I would have yielded in my reaction. And so if I want to, at any point, as long as I know the amounts of copper and the amount of silver nitrate I started with, I can calculate how much silver I was going to yield in this reaction when I mix them together. Finally, I can get an actual yield by performing this experiment and actually collecting silver, and then I can compare my actual and my theoretical yield with that same equation as before, where I take the actual, 35.8, divided by the theoretical, 41.3, times 100 to get the percentage, which would be about 87% yield. So in this case, we have 2 given values, 50 grams of copper and 50 grams of silver nitrate, and we're wondering how much silver are we going to produce. That means that one of these is the limiter and one of them is the excess. So to figure this out, we have to actually do a calculation for both to find out the amount in grams of silver that they will each make. So first, the copper, here's the calculation where we have 50 grams of copper, and then we're trying to find X grams of the silver. And then here's the second calculation where we have 50 grams of the silver nitrate, and again we're trying to find X grams of the silver. See, they both have to solve for the same thing. When we get the answers, this answer gets us 169.74 and this answer gets us 31.75. And so now, because we have two answers, only one of them can be the correct answer, and it's going to be this one. And it's because the smaller answer is always the theoretical yield. And so since this is our correct answer, our theoretical yield, that means that the silver nitrate used to calculate this is the limiting reactant, as opposed to the copper over here, which was used to calculate the larger value, is labeled the excess reactant. And so now you know that when you have two givens, you perform two separate calculations. The smaller answer of the two will be the true theoretical yield, and whoever we used to calculate that smaller answer, that is going to be the limiting reactant. So on page 6 of our note packet, limiting reagent is the reactant that limits the amount of product that's produced by a chemical reaction. So think about our sandwiches that we were talking about. This is the reactant that is completely consumed during the reaction. When the limiting reactant runs out, the reaction will stop and no more product will form. The excess reactant is the reactant that does not get used up during the reaction. There'll be some of it left over after the reaction is completed. So above the equation, you're going to have two given amounts, and then you're going to set up two proportions, and the most important thing to know is that you're going to solve both proportions, and the smaller answer is going to be the true correct answer, and the given of that will be your limiting reactant. And then the one that gives you the larger answer is going to end up being the excess reactant. Let's start with this first example. 3.20 moles of aluminum react with 10.1 moles of hydrochloric acid. Here's my aluminum, here's my hydrochloric acid. Which one of these is the limiting reagent, which one is the excess, and how many moles of hydrogen will actually be produced? So I rewrote the equation here, and I went ahead and identified how much of each I have. 3.20 moles of aluminum, that's this. 10.1 moles of hydrochloric acid, that's this one. And then we want to find the answer of how many moles of hydrogen are going to be produced. So because I have two givens, I'm going to have to do not one proportion, but two proportions, one for each of them. This one here, where I'm going to draw my line, 3.20 moles of aluminum equals X moles of hydrogen, and then I use the coefficient, that's going to be 2 moles of aluminum, and over here we have 3 moles of hydrogen. So that's my first proportion. And then my second proportion I'll do over here, where I write 10.1 moles of HCl equals X moles of hydrogen, and then it's 6 moles of HCl over 3 moles of hydrogen. So I need to do the work for both of these. And so when you calculate this one, we'll do 3.20 times 3 divided by 2. Remember that we want to start our cross opposite the X. And that's going to give us X equals 4.8 moles of hydrogen. Then I'm calculating hydrogen again, except with this reactant instead. So we'll do our cross here. 10.1 times 3 divided by 6, and that's going to give us 5.05. X equals 5.05 moles of hydrogen. So we have two answers. Both of them are for moles of hydrogen, but only one of them is the correct answer. and it's always going to be the smaller answer that's going to be the true theoretical yield. And then what you use to get that small answer is going to be your limiter or limiting reactant. And that means that the other thing that you used is the excess reactant. So to answer our original questions, what is the limiting reagent? We calculated it and found that aluminum yielded the smaller amount of hydrogen as a product, which means the excess reactant must be the hydrochloric acid. And then how many moles of hydrogen will be produced? Well, the answer you got from your limiting reactant is how many moles you'll produce, 4.8 moles of hydrogen. Example number 2, 15 grams of copper chloride react with 20 grams of sodium nitrate. Here's the equation, copper 2 chloride plus sodium nitrate yields copper 2 nitrate and sodium chloride. What is your limiting reagent, what is your excess reagent, and how many grams of sodium chloride are actually going to be formed? Notice we have two givens. That means you have to do two sets of proportions. So I went ahead and rewrote the equation here in blue. I also wrote my given amount above the copper chloride. So I was given 15 grams of copper 2 chloride. We're given 20 grams of sodium nitrate, so I wrote that above here. We're trying to find the grams of NaCl, so I wrote that above here. Below each of them, since we have grams, or we want grams, I went ahead and put the masses of each of them underneath them, because we're going to need those. And then not only should you have the mass, but remember, it's the coefficient times that. So it's going to be 1 times 34.45. This is going to be 2 times 85.0. And this is going to be 2 times 58.44. So now let's set up both of our proportions to see which one is our limiter and which one is our excess. So I'll start with 15.0 grams of CuCl2 equals X grams NaCl. And then underneath, we're going to put this, our coefficient, 1 times the mass, 134.45 grams. And then here, it's going to be this coefficient, 2 times 58.44 grams. That's my first proportion. That comes from this. Now, for my second proportion, which is going to be 20.0 grams NaNO3 equals X grams NaCl. And then down here, we're going to put our coefficient 2 times 85.00 grams. And over here, it's going to be 2 times 58.44 grams. And now we're going to use cross multiplication to get these answers. So I'm going to start my multiplication here, and it's going to be 15.0 and then times 2 times 58.44, and then I'm going to hit divided by 1 divided by 134.45. Notice I didn't divide by the 1 because that doesn't change anything. So here we get X equals 13.04 grams NaCl. Now I'm going to do the cross multiplication over here, starting my cross there, and that's going to be 20.0 times 2 times 58.44, and then it's going to be divided by 2 divided by 85. Divided by 2 divided by 85. And that's going to equal 13.75 grams of NaCl. Now let's analyze our results of what we have. Which of these answers is the smaller of the two answers? And that is going to be this 13.04 grams of NaCl. That is our theoretical yield of NaCl. That means that what I used to get it, the CuCl2, is my limiter, which means the sodium nitrate must be the excess. So that's L for limiter, E for excess, right? Because this one is larger, that means that this was the excess. Because this is smaller, that means this is your limiter. So to answer the questions above, what is the limiting reagent? And we determined that it is the copper 2 chloride. That means that the excess reagent must be the sodium nitrate. And then how many grams of NaCl will be formed? And of the two answers that we got, the smaller one is the correct one, 13.04 grams of NaCl. Final example is, in reality, you're not going to be told when to find the limiter and when to find the excess. You need to be able to look at the problem and know that that is a limiting reagent problem. And how to know that is because you're not only provided one given, but you have two givens provided for you, which means that one of these is the limiter, one's the excess, and you have to do the calculation to figure that out. They want to know what mass of hydrogen gas. So I've rewritten the equation below, and now I'll identify what we're trying to solve for. We're looking for the grams of hydrogen, and this is balanced, 1, 2, 1, 1. So below it, I'm going to put the coefficient times and go find the mass of H2 on the periodic table, which is 2.02 grams. Over here, I am given 50.0 grams of magnesium, so I'm going to put 50.0 grams for magnesium, and then underneath it, I have to put the coefficient times its mass from the periodic table, which is 24.31 grams. And then finally, I'm given 75.0 grams of HCl, 75.0 grams HCl, and underneath here, we're going to take that coefficient times, and then the molar mass, when I add up H and Cl, is going to give me 36.46 grams. So now that I have that, I'm going to do my two calculations, starting first with this one right here. So I'm going to take this, and I'm going to write my given value, 50.0 grams magnesium, and equals, and we're looking for grams of H2, so X grams H2. And then I'm going to take my amounts under here, 1 times 24.31 grams, and then my amounts here, 1 times 2.02 grams. Okay, and then my second proportion is going to be here with my 75.0 grams of HCl equals what we're trying to find, X grams of H2, and under here it's going to be the coefficient 2 times 36.46 grams, and here it's going to be the coefficient of 1 times 2.02 grams. So now that I have both of my proportions set up, I can solve them. This one is going to be 50.0 times 1 times 2.02, and then it's going to be divided by 24.31. So my answer is 4.15. X equals 4.15 grams of hydrogen. And now my other proportion is going to have the cross here, 75.0 times 1 times 2.02 divided by 2 divided by 36.46. Divided by 2 divided by 36.46. And that's going to give us X equals 2.08 grams of hydrogen. And so you've gotten two answers. Only one can be the true, real answer, and of course it's the smaller of the two. So this is going to be the correct answer. This is my theoretical yield. And for the record, that means that this that I used to get it is my limiting reactant, which means that this one over here is the excess reactant. So to answer this question, it just says, what mass of hydrogen are we going to get? You have to do two calculations, and the smaller of those two is the correct answer. 2.08 grams of hydrogen is what we're going to get.